welcome to my YouTube channel. So today we solve the problem of very good number with digits with given digit sum. Okay, so first we understand the problem. The problem says that given two integers and sums, determine the number of n digits, positive integers whose digits add up to sum. An n digit number cannot have leading zeros, that is the first digit must be between 1 and 9. If there exists no n digits number with sum of digits equal to given sum, return -1, right? So the input is 2 is equal to n is equal to 2 and sum is equal to 2. So the answer is 2. Why? So the answer 2 is like we have to n is equal to 2, which means that means the array is only 2, so 1 and 1, which means what is the sum of this? 2. 2 and 0, what is the sum of these? 2. So that is the answer 2, right? So this is the problem. Now I just understand the problem in very easy word, like n is equal to number of digits, right? And sum is equal to required sum of all digits, got it? We need to count how many n digits positive integers satisfy this condition, right? So here we just analyze the thing is first digit from 1 to 9 and remaining digits 0 to 9, that is right. So I just explain the one thing. If I can take this one, simple, right? The simple one, then 1 and 1, right? So 1 plus 1 is equal to 2, simple. Now 2 0, so 2 plus 0 is equal to 2, simple one. So the answer is 2, simple. Now same type, there is n is equal to 1 and sum is equal to 10. So we just start from the n is equal to 1, which means 0 1 2 3 4 5 6 7 8 9 is there. If we can add, so can we get the 9? No. We can get the 10? No, we can never. Why? Like n is equal to 1, got it, and sum is equal to 10. Now just think, if 0 we can add, then we can get the no. 1 then no, 2 then no, 3 no, 4 no, 5 no, 6 9 7 no, 8 no, 9. There is no chance. Why? Because n is equal to only for 1, so we can take the only for 1, but sum is 10, there is no chance to 10, that means get the sum, so return -1. So this is the problem, simple one. Now you understand. Now here we can come on the brute force approach. If we analyze and we can just use the as a brute force approach, so what we have to generate every n digits number, we have to generate every n digits number for, like here is I just comment it out, okay, like n is equal to 9, right? So what is, so 1, that is the 9 to 9. I didn't count the 9 how much, but yes, I just count the 9 to 9. So nearly 90 millions numbers, 900 millions number. So is there possible? No, there is not a possible. So for that reason, so if like this type of the use number, so if we have the use number, then we can use the dp. So here we can use the dp, right? So dp, we just suppose we are filling digits one by one. Like how can we filling the digits? Simple one, like if use dp, right? So here like n is equal to 3 and sum is equal to 6. Now here I just at every position choose one digit, right? Like keep track of current position and remaining position, got it? So this becomes dp, which means keep and remaining, right? So here, so what we have to do, so the number of ways to fill digits from positions pause onwards, so the remaining digit is sum, right? So we just have to the think as a recursively thinking, like n is equal to 3 and sum is equal to 6. So choose first n digits, like it can be 1 2 3 4 5 6. Yes, it can be not greater than remaining sum, right? Suppose we choose 2, that is n is equal to 2 3, and we can just choose n is equal to 2, so the sum is equal to 4. So what we have to take, then we have to get that 4, so we just take this, and that means 0 to 4, and then we can get this, right? So this is the problem, and this is the solution. So in that, I just tried the base case. I just explained what is the base case. Base case is if all digits are filled. Like in that, if all digits are filled, then position is equal to n. If नहीं, then sum is equal to 0. So one valid number found. एक बार में हम लोग एक वैलिड नंबर फाउंड करेंगे ही करेंगे, then we can get this. So without any further delay, I just write the memorization code, right? Memorization code, if I can just memorize, I just first explain and then I will write the code, write the time complexity, then you will understand, right? So here, start from here. So if we can start, then there is the if sum greater than is equal to 9 into n is equal to sum greater than is equal to 1. Got it? And then return -1. Right? Now here mem set dp of -1 and size of dp. Right? Now in answer is equal to solve of 0 and sum, and then simple return answer is equal to 0 -1 and answer. Right? I just write the function of this function, right? Int dp is equal to, I just assume dp is equal to 10 and 82. It will take for the all the numbers. Now int solve and int position, int and int sum. Right? Now here if position is equal to, that is the base case, so here is return sum is equal to 0. Right? If dp of pose sum is not equal to -1, then return dp of pose and sum. Simple. Right? Now int way is equal to 0 and int start is equal to pose is equal to 0 1 and 0. Got it? So this is, now just start the one loop, simple sa loop 1, start for int digit is equal to start and digit greater than is equal to very little 9 and digit plus. Now if digit greater than is equal to sum and then ways plus is equal to solve of cos plus 1 and sum minus digit. Right? And then return dp of pose sum is equal to way. Right? Now just try to compile it and see there is any problem and any error. Yes, the problem is ways was not declared. Okay, which number line? 19 line of ways, and here is way. Okay, now any other was any another? No. Try to submit it. So here we can assume like What is the time complexity of this problem? So the time complexity is very simple. The time is order of n into sum into 10, right? So we can just take the order of n into sum, right? And a space is order of n into sum, right? That is the memoizations. There is the tabulation, that means top to top up and the bottom to top, bottom to up. We can also write this. So this is that this is a your that is meant. You just write on the comment box to these solutions. If you will not get, then I will paste it in the comment. So thank you.